So we've discussed in the past how to find the slope of linear functions. And what's so nice about those is that if you have a linear function, and I ask you to find the slope of it, you could pick 2 points on that line, and you can find the slope by figuring out what change of y occurred and divide that by the change of x that occurred. Okay? And the nice part about linear functions is that if someone else comes along and picks 2 different points on the same line and then calculates the same ratio, the change in y over the change in x, they'll get the same number. Okay? And that's because linear functions have a constant rate of change. Okay? And that was sort of your first experience with slopes. The other thing that was sort of, well, you sort of knew about this, is that to find slope, you needed 2 points. Okay? And if I have 2 points, finding slope's easy. I can find change in y over change in x. I know what to do. Everything's fine. So let's state a goal for today. Goal is going to be this: to find the slope of y equals the square root of x. And before you even finish the sentence, you should start to be a little bit nervous, because y equals square root of x looks like this. It is not a linear function. So we can say that the slope changes, right, as x changes. So this question better be pretty specific. I'm going to say find the slope of y equals square root of x at x equals 4. If you think about it, this problem's a little bit special now, because we're going specifically to x equals 4, and we're saying, hey, what's the slope there? And geometrically, what we're really doing is we're finding the slope of the tangent line. That's our goal here today. All right. There's only one problem. I only know how to find slope if I have 2 points. I don't know how to find slope at just 1 point. So here's what our plan is going to be. I'm going to try and find some estimates for slope. That's what I'm going to try and do. Okay? So I'm going to pick a point nearby. This is going to be my first estimate. I'm going to go to x equals 5. I'm going to go up to the curve and put a dot there. And I know the coordinates of that point. That is 5 comma square root of 5. Just like I know the coordinates of this point right here when x is 4. That's the point 4 comma 2 coming from the square root of 4. So I am going to find the slope of the secant line that connects them. Well, we discussed that already. The secant line is a line that goes between 2 points that are on a given function. So we're going to find the slope of that secant line. I'm going to call this line L sub 1. That's my first secant line. And the slope of that secant line is going to equal square root of 5 minus 2 over 5 minus 4. Okay, I'm going to need some calculator help here. Let's type this in and see what we get. So this is about 0.2361. Okay, so there's our first estimate for the slope of that green tangent line that I'm trying to find. All right, well, my claim is we can do better. I picked 5 because 5 I thought was pretty close to 4, but we know we can get closer to 4 than just x equals 5. So that's what we're going to do next. Let's draw our picture again. Here's our y equals the square root of x. Here is 4. I'll go up to the curve. This picture isn't perfect, but it'll do. This is 4 comma 2. We're trying to estimate the slope of that tangent line there. And now instead I'm going to pick up a number that's closer to 4, like 4.1. And I'm going to go up to the curve and put a dot there, and I'm going to draw in a little secant line. So now, here's what I think. I think the slope of this new secant line is closer to the slope of the tangent line that I want than in the other picture. In the other picture, I think this secant line that we drew here, that was a decent estimate for the slope of the green tangent line there. But I think this one's going to be better because I picked the second point, x equals 4.1, which is closer to 4. All right, so I'm going to call this line L2, and then the slope of L2 is equal to the following. Now, I don't know what this is, but I know this point can be found by doing 4.1 square root 4.1. So my slope is going to be the square root of 4.1 minus 2 over 4.1 minus 4. And an estimate for that turns out to be 248.5. Okay? So this is my second estimate for the slope of the green tangent line. So this is good, but we can do better, and that's what we're going to do now, and then and see what happens. Okay, so here it is. Here's y equals the square root of x again, and here's that point. Here's x equals 4. This is the point 4, 2. There's the tangent line that we're trying to find the slope of, and now we're going to get even closer. So this time I'm going to pick x equals 4.001. That's really close. And then we draw the secant line in there. It looks really close. In terms of the slope of that secant line, it looks very similar to the slope of that tangent line. I think these lines are almost parallel. So let's see. Okay. This point has coordinates 4.001, comma, square root of 4.001. Okay. So now we'll call this secant line, to be consistent, L3. The slope of L3 is going to be square root of 4.001 minus 2 over 4.001 minus 4. And my assistant tells me that this is about 0.24998. Wow. Okay. So I think we're just about ready to start drawing some conclusions, right? Let's think about our different secant lines and their slopes and what's happening to them. So maybe we'll make a little chart here. So here it is. This is going to be the line, and this is going to be the slope. Make a little chart for ourselves so we can sort of summarize things. So we had line L1, which went from the point 4, 2 to the point 5, comma, square root of 5. And that gave us a slope of, this was our first case, 0.2361. Okay. Our second line went from 4, 2 to the point 4.1, comma, square root of 4.1. And that gave us a slope of 0.2485. And then our last line, L3, went from 4, 2 to the point 4.001, comma, square root of 4.001. And that gave us an answer of 0.24998. Okay. It's time for us to make a conjecture. It's time for us to say what we think these slopes are getting closer and closer to. And if we look at it, it looks like our slope is getting close to 0.25. Okay? Now, this should feel like a limit, right? We're saying as the second x value, 4.001 gets closer and closer, x equals 4, our slope, if our secant lines are getting closer and closer to 0.25. So what I'd like to do is prove this somehow. I'd like to know for sure that the limiting value is 0.25, and that's what we're going to do to finish this off. Okay, so we're going to draw a picture. It looks very familiar. Here we go. Here it is. Y equals the square root of x. Here's a point 4 that we're interested in. And let's think about what we've been doing so far. So we'll pick a second point nearby. And we're going to pick it using the following idea. We're going to say that it's 4 plus some very small number, which I'm going to call h. I shouldn't say small number. I should say a number that's close to 0. So what I'm doing here is I'm picking a nearby point, 4 plus h, which is really close to 0. Okay? We draw in the secant line between those 2 points, And I'm going to call this one called L sub S, L secant. Okay? So let's find the slope of that. So m of L sub S would equal, well, I need some points. The first point is 4 comma 2. Very familiar point. Second point is going to be 4 plus h, comma, and to get the y value, that's right, the rad of 4 plus h. There are the coordinates of that other point. So now we're ready to write the slope of our secant line. So it's going to be the rad of 4 plus h minus 2 over 4 plus h minus 4. Okay, so that's the slope of our secant line. There's just one subtle little piece missing, and that is we need to write down somehow that h is close to 0. But we have a way to do that we've studied. We have a way to indicate to someone that we want h to get close to 0. So this is it. So we're ready. We're going to find the limit as h goes to 0, the square root of 4 plus h minus 4 over 4 plus h minus 4. And if we do that, we're going to find what the limiting value is of the slope of the secant lines. Well, we know how to do this limit. First off, you can cancel some stuff. 4 and minus 4 cancel. And now we're left with this. Minus 2. This should be 2. Oops, I made a mistake there when I wrote it down again, I think. I had 2 up here, and I just didn't copy it correctly, so let's be careful. 2. And then here, h. Well, we know how to handle radical expressions like this numerator. Right. Multiply by the conjugate. Multiply by conjugates are nice. It does a nice thing for us. Watch what happens. When we do rad of 4 plus h times rad of 4 plus h, we get just 4 plus h. And then whatever that term is, it's going to cancel with that term because it's the same product, but one's positive and one's negative. And then lastly, these guys give us a minus 4. And on the bottom, we have h times the square root of 4 plus h plus 2. And you'll notice that on the bottom, I did not bother to distribute that h. I mean, I could have done that, but I don't want to. Let's watch what's going to happen next. I'm going to cancel those 4's, and this becomes h over h times the square root of 4 plus h plus 2. And then the h's cancel. Wow, wow, wow. Limit as h goes to 0, 1 over the square root of 4 plus h plus 2. And for the first time in this limit, I can plug in h equals 0 and not get something that's undefined. So let's do that. I plug in h equals 0. I end up getting 1 over the square root of 4 plus 2, or 1 over 2 plus 2, or 1/4. Well, that's amazing. That's what I thought the slope was getting close to in the first place. And we just proved it.